Look at the data from the z-axis inspection point. The tolerances are tighter than the previous run.
Confirmed. We are seeing a 5% improvement in throughput.
Our new facility utilizes advanced machine vision to ensure unparalleled quality control across the production line.
The temperature differential on zone 3 is still fluctuating outside parameters.
Let's check the reflow profile history on that batch.
By analyzing the heat map data, we can optimize the reflow process and minimize defects during the manufacturing process.
The thermal imaging confirms 0 defects on this batch.
Good. Let's increase the throughput on line 3.
Using advanced machine vision, the system captures multiple angles, comparing the data against the digital twin in real time.
As you can see on the heat map, the temperature differential is within the acceptable parameters for the stress test.
The digital microscope allows for micron-level inspection, crucial for detecting anomalies in the reflow solder process shown here in the thermal overlay.
The heat map shows a slight variance on the z-axis.
We should recalibrate the robotic arm's placement.
The machine vision cameras ensure unparalleled precision, scanning each component for microscopic flaws before advancing to the next stage. Quality control is paramount. Here, human expertise meets advanced machine vision to ensure every component meets our rigorous standards.
Precision is paramount. Here at the quality control stage, every component is scrutinized against the strict.
This heat map shows a slight deviation in the thermal tolerance.
Yes, we should check the calibration on the next run.
I've signed off on the current batch. The robot handled the stress test sequence.
Good. Let's review the heat map data before we clear the conveyor. Machine vision allows for real-time inspection, ensuring unparalleled precision at every stage of the assembly line.
The thermal mapping looks good on the secondary capacitor.
Yes, and the vibration analysis show consistent tolerances. It's a pass.
Our advanced machine vision system uses high-resolution cameras and lasers to ensure every brake component meets our rigorous quality standards.
The laser scan clearly highlights the stress points in red.
Exactly. This allows us to refine the design parameters immediately.
The machine vision system flags components that deviate from the tolerance levels, diverting them to the suspect parts bin for further analysis.
The throughput stabilized after the last adjustment.
Yes, but the rejection rate is up slightly on the east line. We should investigate the heat map data.
We've decreased the defect rate by 15% this quarter, exceeding our targets.
The model correctly identified the microfracture on the defective unit.
And the heat map confirms the stress point localization.
The heat map confirms the thermal irregularity in the scan.
The cracking correlate exactly with this high temp zone.
The system automatically flags potential issues. Then we manually sort them into the appropriate defect categories for further analysis.
As you can see, boosting the visibility here allows the heat map to clearly identify that anomaly.
The surface deviation is within tolerance, but look at the thermal signature here.
Yes, the cooling cycle needs adjustment.
Warning, upper tolerance limit reached on dimension 4.
Acknowledged. Initiating process adjustment sequence.
There's a critical failure on Unit 42. The vision system caught the anomaly.
Okay, isolate the batch. Let's analyze the root cause immediately.
Check the tolerances on this section here.
The heat map shows we are within the acceptable range, but let's monitor the next batch. The thermal readings are stable here. They look fair.
Good. The new joint should resolve the vibration issue.
The contrast between the worn edge and the new one clearly illustrates the impact of fatigue on component integrity.
The quality performance indicators are all green across the board.
Excellent. Let's maintain this calibration for the next shift.
As you can see on the timeline, this spike correlates directly with the shift change on machine 3, indicating a training issue.
The AI predicted failure at 15 kilonewtons.
The hydraulic press achieved pacing 1-2.
There's the failure point. The sensors captured everything up to the snap.
Let's cross-reference this with the batch data from Q3.
Look at the stress concentration right here on the heat map.
Yes, the fracture initiated exactly where predicted.
By leveraging AI across the production line, we've achieved unprecedented levels of quality control, particularly in the automotive division. This data clearly shows how we've achieved a significant reduction in scrap, which directly correlates with the fewer customer complaints we've received this year. The Q3 improvements are clear here.
Yes, the machine vision reduced defects by 15%.
Motors. This state-of-the-art facility utilizes advanced robotics and machine vision to achieve unparalleled.
The solder joint analysis on Sector 4 looks good.
Agreed. The thermal profile is consistent with the new parameters.
Machine vision ensures quality control, identifying subtle defects like this solder bridge before they cause failure.
The thermal signature here suggests a slight deviation in the reflow profile.
Is it within tolerance for the automotive clients?
The machine vision system captures high-resolution data on every unit, ensuring zero defect manufacturing.
By integrating the new machine vision cameras, we can reduce the error rate significantly.
And the timeline for the automotive integration looks solid for Q3.
This layout increases efficiency by 15%.
And the machine vision cameras ensure quality control at this junction.
By implementing AI inspection at these key stages, we've reduced the margin of error significantly. The predictive
The throughput on conveyor 4 is dropping.
Yes, I see the spike on the heat map. Let's run a diagnostic on the vision camera.
The thermal signature on the new batch is consistently lower.
Yes, the calibration seems to have stabilized the variance.
As you can see on the tablet, the AI highlights the anomaly in red.
Yes, I see the heat map, so I acknowledge it here.
Correct. That clears the alert.
Go.
These heat maps allow us to visualize potential issues in real time. The critical alerts, shown in red, require immediate action.
In this modern medical device clean room, precision is paramount. Our automated inspection systems
The precise rotation allows our machine vision cameras to detect microscopic flaws, ensuring every component meets the highest standards. The automated inspection cell utilizes advanced machine vision to ensure the integrity of every aerospace component.
The z-axis deviation here is unacceptable.
Yes, it's clearly outside the specified tolerance. We need to adjust the feed rate.
As you can see, the real-time data aggregation across all plants allows us to maintain our zero.
Zoom in on the heat map for Station 4. We needed to verify the torque calibration before the next cycle.
The heat map on the current batch shows a clear anomaly in Sector 3.
Yes, the vision system caught that immediately. We need to adjust the calibration on the robotic arm.
Our integrated quality control systems utilize both machine vision and expert manual inspection, demonstrating true human-machine harmony.
Using the tablet, the inspector can quickly verify the quality control data for the entire batch. The timeline shows a slight deviation in the z-axis calibration here, triggering the alert we saw earlier.
By leveraging machine learning and precision robotics, the defect rate has been minimized, ensuring
The heat map shows consistent overheating in this sector. We need to adjust the parameters.
I agree. Let's cross-reference that with the robotic arm calibration logs.
Look at the throughput on line 3 since we implemented the new inspection protocol.
That's a 20% gain. The predictive maintenance model is working.
See the direct correlation here? The yield jumped immediately.
Confirmed. The adjustment stabilized the process.
Our advanced machine vision systems ensure unparalleled precision, monitoring every component in real time.
This facility represents the pinnacle of connected manufacturing, integrating advanced robotics and strict.
The vision system is flagging a recurring anomaly on Sector Gamma.
Let's check the heat map. It looks like an alignment issue on the feeder.
The thermal imaging shows a consistent hotspot right here.
We need to adjust the parameters before the next cycle.
Look at the stress points highlighted here. The new alloy seems to be performing better than expected.
Agreed. The heat map shows a significant improvement in distribution.
The machine vision system detects anomalies with incredible precision, highlighting critical areas in real time.
The thermal signature on this component is still running high.
But the stress test results are well within tolerance. Look at the chart. The thermal imaging confirms the stress point here.
Yes, the depth analysis shows it's penetrating the substrate.
How are the readings on the latest run?
Consistent with the previous calibration, 25.003.
We need to monitor the data stream closely right here.
The heat map shows a potential anomaly in the solder paste inspection.
The high-speed cameras capture even the minutest defects, ensuring unparalleled quality control across the production line.
Our machine vision system analyzes each component time, utilizing abstract heat maps to
The machine vision system inspects the brake components for microscopic flaws, ensuring zero defect delivery to the next stage.